Hi Year 9. It's time for much excitement because this is the last video for the week and it's past 9 o'clock on a Saturday night, so yeah, I'm really raring to go to get through this one with you all. So perimeter, we were talking about length and perimeter in the last lesson. This one merely extends our discussion a bit further to the perimeter of circles and sectors. What are sectors? Sectors are just parts of a circle, so we're just looking at circles and finding distance around them today, which is cool because it involves pie, and we all like pie. Some meat pie, some apple pie, but we all love pie. So let's do this. Here's a circle. I'm hoping that you may recall what this is. If I drew a line here, what does that represent in a circle? That's right, it's radius, which you'll often see depicted as the letter R. And if I drew a line completely through the middle there, what's that thing called? D, the diameter. All right, so who remembers the formula for the circumference, because that's the name for perimeter, of a circle? So circumference, which is perimeter, of a circle, C is 2 pi r. That's the most common form that you'll see. There's another form that you can write, because what's 2 times r? 2 times r would give me d. So I could also write this as pi d. You know what, I don't mind which one you use as long as you adhere to the glorious rules of mathematics. So a quick example of that. Let's say we had a circle here. Distance there. Let's say it said 6.2 meters. Very big circle. I don't know what on earth you're going to do with it. Play some game. That's cool. And to find the distance around it, the perimeter, always called the circumference, all we would do is we write, this is important, always write down the formula. I'm sure I've had this nagging conversation with you already this year, but we write the formula, then in the next line, we put in the values. So the radius was 6.2. And finally here, we're going to put it in our calculator. Make sure you are using the pi button, the proper pi button, which you get by, I think on the other Casios it's the same. Shift the 10x there, look for the little pi symbol. So get the proper pi value from the calculator, times 6.2, and it'll give you something like this. It is an approximation. We're going to be doing a rounding here. So I'm getting, turn it to the approximately equal signs, the wiggly equal signs, and I'm getting 38.96 meters when I round that. So that's not too bad. In fact, you know what? I'm going to give a more interesting question than that, and something like this. Right, if the circumference is 7.6 kilometers, what is the radius? So all the way around it is 7.6 kilometers. And what's the radius? Now, that's a more interesting question, isn't it? So let's do that. Now, all right, so we know the formula. We know C is 2 pi r. We know that the circumference is 7.6, so I can put 7.6 in as C, and it's going to be then 2 pi times the radius, right? 2 pi r still over here. To get the radius by itself, this is where we need a very small amount of algebra. What's the opposite of multiplying something by 2 pi? dividing by 2 pi. So if I divide both sides by 2 pi, all you'd be left with on this side is the radius, so I'll write r, and then on this side you'd have 7.6 divided by 2 pi. Now, we're actually going to talk a bit about exact values in this process too. I could leave it as that, because as soon as I put that in the calculator, I have to do rounding, because pi goes on forever. Exact values, you can leave things with pi in them. We may or may not do that later in the lesson, but for now, I'm just going to put it in the calculator. 7.6 divided by 2 pi, and the radius is approximately 1.21 kilometres. Remember to include our units. So that's the first half of this, the circumference of a circle. We are now going to work out the perimeter of a sector, so part of a circle. All right, I need to get rid of that. Say goodbye. All right, so let's say you had part of a circle here. Whoa, that's terrible. So we're going to have... this board is not the easiest to write on, I'm telling you. And it's going to be a kind of Pac-Man-like thing, you know? Something like that. And I'm going to put the angle of... in here, we're going to put an angle, well, it's somewhere between 180 and 270, isn't it? 243 degrees, there we go. And I'm going to call the distance here, that can be 5.3 centimetres, which probably isn't too far off what it actually is in this case. So, how would you find the perimeter, the distance around this thing? Well, I think some of you could probably work out how to do this without me going through it, but let's work out a general case. So this is the perimeter of a sector. Now, recall for a circle that the perimeter was, what was it? C is 2 pi r. Well, there's a few things different about a sector, isn't there? Firstly, these straight lines here are part of the perimeter now. What's the length of each of these? The radius, right? The length of that's going to be the radius. The length of that's going to be the radius. So, firstly, we've got 2 copies of the radius whenever we're looking at the perimeter of a sector, right? Radius there, 2 copies of the radius. And then we've got to think about this round bit here. And you may or may not realise that it's not actually too bad there. It's the proportion of the circumference depending on how many degrees. So how many degrees are there in a circle? There's 360 degrees, right? It's going to be the angle divided by 360, which gives you the proportion of that outside bit that you need to include, times the old 2 pi r. I mean, think about it. If you had 90 degrees in there, it would give you a quarter of the circumference. And that makes sense. If you put 180 degrees in there, it would give you half of the circumference. It makes sense. So that's what you need to do. It's a little bit more involved, but it's okay. So in our case here, we'll do it with what we had there. It's 2 times 5.3, 2 times the radius, plus the angle was 243 degrees over 360, times 2, times pi, times the radius of 5.3. Right, now, in this case, you're probably going to put it in the calculator. you can't take it too far keeping it in exact form. In this case, well, it's going to be a messy exact form anyway. So here I'm going to do 2 times 5.3 plus 243 over 360 times 2 times pi times 5.3. 33 over 360. Yep. And it gives me that. So a bit of stuff to put in your calculator, and it's going to be approximately 33.08 centimeters will be the perimeter of this object. I need to do one quickly where you can answer it using exact values. A lot of the examples I do for your class here involve decimal numbers and that sort of thing, and that's because I want to make them slightly harder for you. But I'm going to do an easier example very quickly just to show how you would answer something using exact values. As I said, exact values mean you can leave pi in your answer. That's the biggest consequence in terms of this. It's just leave pi in the answer. So I'm going to do a second example. I'm going to just do half a circle. Half a circle, and I'm going to make it that we know the distance over here. So the distance from top to bottom here can be 10, what units haven't we used lately? 10 millimeters, there you go. And the question is, what's a perimeter? So if you write the formula for something like this, it should be what we had before, 2r plus theta on 360 times 2 pi r. We put the values in. There's a trick here. What did I actually give you? I gave you the diameter. So we do need to note the radius is 5 millimeters, isn't it? Very important before we put the values in there. And if it's half a circle, what's the angle in there? 180, right? So that's 180 degrees. You need to be able to pick that up. So 2 times 5 plus 180 over 360, which is the same as a half, and I am going to change that to a half in a moment, times 2 times pi times the radius of 5. Let's clean that up a bit. 2 times 5 is simply 10. That is just a half. 2 times 5, when you multiply things together, remember when you multiply things together, you can do it in any order. Like 2 times 3 is the same as 3 times 2. So we can rejig the order of this. 2 times 5 would just give me 10. And we still have a pi in there. A half of 10. Remember, multiplication is the same as saying a half. So a half of 10 is 5, giving me 10 plus 5 pi. That is the exact value. If you're asked for the exact value answer, that's what you do. All right, we haven't done any rounding, any approximation, but the second we actually put a value of pi into that, we'll start doing rounding. So exact values still have the pi in it. If you want to be really fancy, you could actually apply some of the algebra we've used recently and realize there's a common factor of 5 in that, which is really going fancy. 5 times what gives us 10, and 5 times what gives us 5 pi. You could write it in that form too if you're feeling particularly excitable on when you're doing your work, but that's not quite necessary at this stage. If I was to, get a approximation of it, we'd put it in our calculator, 10 plus 5 pi, and it's approximately 25.71. So at that point, we'd be putting in our squiggly equal sign because we've gone into approximations as opposed to exact values. So remember that, guys, if you're asked for exact value, leave the pi's in it. We have gone over how to find the perimeter of a sector, the circumference of a circle. In other words, we went through how to find the distance around a circle and how to find the distance around a sector. You need to be able to do that in a range of different situations. You need to recall your formulas. There's your circle, there's your sector. You need to be able to use them, and if you ever see any reference to exact values, just leave the pi in it and clean it up as much as possible. All right, have fun. I think that'll do you.